type definition gives a name to a data type by creating a new type that can then be used anywhere a type is permitted. So generally, this type def allows the user to create what we call a custom, right, data type. And of course, this is not really the case. You can think of this type dev as a facility to basically create, right, an alias of an existing type. For example, if we said type def, right, this is the keyword, int is int, right? We can redefine, right, this native, right, integer to have a different name called int. Of course, this is not recommended. You never want to, redefine any primitive type, right, to have an alias, something else, unless, right, this entire primitive or this type is rather complicated. So we'll look at a couple of an example. So this is the format, right? The keyword type def itself plus the type. So this type, right, is any standard or derived type, right, in C or C++. In fact, in C++, you can do this as well, since they're C++ backward compatible. And then you specify an identifier. Traditionally, this identifier is uppercase, but you don't have to have it in the uppercase. You can have it, in camel case and whatnot, but it's better to have it in uppercase just because this is the standard practices that we have here. A lot of times, software developers use type def to simplify code. This could be the example. Let's say if you have a char start, right? And this char start is some sort of array pointing to something else. We can, instead of writing this char start, we can have this written as, and then of course you have to define this, right, with type def. Char start, right? And this will be your type. And you can set this entire thing is str, right? So in the following line, and of course, this is a statement. In the following line, right, we can then set str, right? Moving forward is all going to be char start, right? And this is in the context of your code. You can set arr array to something, right? 20 or 100 in this case, right? So this allows you to represent. So this is the old way of writing it, right? And this is a new way of writing it. One of them is the more complicated way of writing it, and the other one is more simplified way of writing it, right? So these two are equivalent. Another example of using type def to simplify code is, for example, let's say if you have some sort of unsigned, right? So unsigned means everything's positive, right? Integer, right? int, right? So instead of saying, declaring everything as an unsigned in, right? X, Y, and Z, you can then use int, right? X or Y, right? So on and so forth. So you don't have to write out the whole thing here. So this is another example of where the type def could be used. So note that we can use type def to give a name to your, other user-defined data types, such as structure, right? We'll talk about structures in a different video. You can type def a structure, for example. And note that type def is a compiler feature. The interpretations of your type def is performed by the compiler, right? So this is a little different than pound define, right? Pound define, right, is used to define an alias or value. Let's say pound define true, right, to have value of 1, right? There's no semicolon. So this entire thing is a preprocessor definition, right? Preprocessor definition is the very first stage of your compilation process, right? So it's search and replace, basically, right? And then your type def interpretation is performed by the compiler, right? So this means that your compiler is going to look at, right, your type definitions and see what they are, and the interpretations of your int in this case is done at the compile time. So your object code, as a result of the compilations, will then have these logic that indicates that all of the unsigned in Moon4 or the use of INT to represent it.